All right, so the next thing we're going to talk about is looking at resistors in series and in parallel. So let's say that we had some resistors. Now, you know how like when you're on Netflix and you just start watching like Frasier and they're like, do you want to keep watching? And you're like, sure, because getting up and like doing anything else with my life sounds like totally not worth the effort. And so you end up watching like 300 episodes of Frasier. Okay, well that's kind of like what resistors in series are, because when you watch a series, you watch the first one, and then you watch the next one, and then you watch the next episode, and then the next episode, and then the next episode. All right? So one of the things that's kind of special about resistors is the current across all resistors is the same. Okay. Okay. So whenever you're looking at something, like if I have a little dude, this is little current electron dude. All right, little electron dude, and he's like, doo-doo-doo, oh, I'm going to go through here. All right, well, little electron dude is still here, and he's like, doo-doo-doo, and electron dude here's still, and then he has to keep going, okay? So if you enter, you have to keep going. That's kind of the game whenever you have resistors in series. Now, let's say that the resistances on these resistors is, say, 5, 12, and 20. So this little dude comes through here, and he's like, oh, man, that was exhausting. So he's like here he's happy, and here he's like, eh? And then here he's like, oh, I have to go through 12 again, and he's like getting sad, and then he has to go through 20, and now he's like super angry electron. Okay, so that's because as we go through something in series, it's like you have to go through the 5, and then the 12, and then the 20, and you don't get a break. And so whenever we have resistors that are put together in series, what happens is the equivalent resistance is going to be equal to the sum of all of the resistors themselves. So however many resistors you have, if they are all in series, then the equivalent resistance is the sum of all of them together. So if I had to go through a 5 and then a 12 and then a 20, then that would be the equivalent of going through a 5 plus a 12 plus a 20, which would be a 37 ohms. So that would be the equivalent of going through 37 ohms. Does that make sense? Okay. Now, let's get rid of angry little dude. Okay, so now he's got a lot of friends. So let's say he's got 10 amps worth of friends. I feel like this is bothering me. What we are currently looking for is not in anything in parallel. Right now we're only looking at stuff in series. We'll do parallel another time. All right, so I have 10 amps coming in. So little friends, 10 amps. Now I know that V is equal to IR. So the voltage across each resistor is equal to the current running through it times the resistance. And we know that the high pressure is on the side the current enters through and low pressure on the side it exits from. So enter, exit, enter, exit. So the voltage across the first one is equal to 50 volts, 5 times 10. Then we have 10 times 12, 120 volts, and then 10 times 20 is 200 volts. Now, I'm saying something pretty particularly. I'm talking about the current that goes through something, but I'm talking about how the voltage goes across something. So you can think about it. If I'm standing here and I'm watching current go by, I can be like, check it out, lots of currents passing me, it's crazy. But if I'm standing right here and I'm like, am I at low voltage? And I'm like, I don't know. I can't really tell if I'm super stressed unless I kind of compare it to how I felt last week. So I can't tell that I'm at low pressure unless I compare to something else with high pressure or similar. I can't tell that I'm at high pressure unless I compare to something going on at low pressure. It looks like little headphones. So whenever you've got a voltmeter and you're measuring voltage, you're always going across an element, whereas anytime you're doing anything with current, the current is going through an element. So we're measuring the current through, but the voltage across. So we have this 10 amps and going across the whole thing. So what we see is there's a 50 volt drop, 120 volt drop, and a 200 volt drop, which means all in all, I have a 370 volt drop across all those resistors, which is pretty intense. But it matches actually, because if I come over here and I look at my equivalent resistance, if I have 10 amps going into a 37 ohm resistor, I've got a high end and a low end. I got 10 amps coming out the other side because anything that goes in has to come out. So 37 times 10 is 370 volts. So this is an equivalent system. If I needed a 37 ohm resistor, I could just create it by having a 5 ohm, a 12 ohm, and a 20 ohm. So again, something that's really important to notice is that when you have resistors in series, although the current across all the voltages is the same, the voltage is not. So voltage is not the same in series. And this is a really big deal that you want to make sure you keep this straight. And it kind of makes sense. So if you're getting confused, if you get on the test, you're like, what am I doing again? Just remember stupid little electron dude going derp, 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 and he's like, has to go through. So the current has to be the same going all the way across, but that means therefore the voltage does have to be different.